Okay, now time for question 11, section C now. So a car is traveling at a constant speed of 90 km per hour. So do take note, this is constant speed, it's 90 km per hour. They want us to find the distance traveled, okay, by the car in half an hour. Half an hour is actually t, 0.5 hours. This is the speed. Okay, so to find the distance traveled, it's not too difficult, so we know distance is equals to speed times time. Now you can only use speed times time if you know that it is a constant speed. So 90 multiplied by 0.5 hours, so you get 45 kilometers. So distance traveled is 45 kilometers. Now let's look at part B. Okay, the car in figure 11.1 is traveling along the road, which there's a speed detector. It consists of two parallel strips attached to the road connected to a timer. The speed detector strips are 0.5 meter apart, so there's a fixed width. They are 0.5 meters apart. Okay, the time interval between the car hitting the first strip and the second strip is 0.04 seconds. Calculate the average speed. So we know that the average speed, to find that, we just take the distance divided by the time taken. Okay, so 0.5 divided by 0.040. So what we're going to get is 12.5 meter per second. Do take note the units here is meters, the unit here is seconds. Okay, so the average speed is 12.5 meter per second. Now, figure 11.2 shows the motion of a lorry at different time interval during part of a journey. Its speed was recorded every 5 seconds. Okay, every 5 seconds. Now on figure 11.3, plot the 5 points and draw a graph to represent the motion of the lorry for the first 20 seconds. So let's just plot it. So it is at time equals 0 seconds, the speed is 0. So we plot over here. When it's 5 seconds, it is 10 meter per second. So 5 seconds is 10 meter per second. At 10 seconds is 20. 10 seconds, it is 20. Okay, at 15 and 20 seconds, the speed remains at 20. Okay. Now, so we're going to plot the graph for the first 20 seconds. So once you have plotted the points, all we need to just do is just connect them together. Okay, connect them together. Yep. So this will be part 1. Now, part 2. Okay, use your graph to calculate the distance traveled by the lorry in the first 20 seconds. So the distance traveled, now I need to find distance traveled. Now you can't use speed times time just like this because it's not a constant speed throughout the whole thing. So distance traveled in this case here, whenever you have a graph, you find the area under the speed time graph. So what we're going to do is, let me use a different color to just show you. We're going to use this triangle over here. Okay, so we know the base is 10, the height is 20. We're going to have a rectangle over here. The base is 10 also, the height is 20. So what we're going to do is we're going to have, let me get back to the red color. Okay, this equals to the triangle of base 10, height 20, plus a rectangle of base 10, height 20. So this half times 10 times 20 plus 10 times 20. So what they're going to get is 100 plus 200. So the distance traveled is 300 meters. So the distance covered is 300 meters for the first 20 seconds. It says the lorry then continues to accelerate at a uniform rate of 0.45 meter per second for 15 seconds. So, and then it's finally brought to rest in a further 20 seconds by a constant braking force. Now, whenever you have a constant braking force, means that the deceleration, okay, the deceleration will be constant. Okay. Now in figure 11.3 show how the speed of the lorry varies with time for the remaining 35 seconds. So let's think in terms of the final speed. Okay, so at 20 seconds the speed is 20, but it says it's going to accelerate 0.45 meter per second squared for 15 more seconds. So let's just use the formula. Okay, acceleration equals to the final speed minus the initial speed divided by the time taken. So we know that acceleration is 0.45. We know we want to find the final speed after the 15 seconds. We know that the initial speed, which is at the 20-second mark, is 20 meter per second. Okay, so this will be the formula we're going to look at. So 0.45 multiplied by 15 equals to V minus 20. So 0.45 multiplied by 15, you're going to get 6.75 equals to V minus 20. So V is equals to 26.75, okay, meter per second. So we know that 15 seconds later, so at 35 seconds, the speed is going to become 26.75. So 35 seconds over here, so this 35 seconds, the speed is going to become 26, 25, 26.75, so it's over here. So we know that from 20 seconds to 35 seconds, it accelerates uniformly, so this is going to be a straight line with the speed increasing like this. Now, then it says it's brought to rest. Rest means the speed becomes 0, okay, in a further 20 seconds. So we know that 20 seconds later, so at 55, okay, the speed becomes 0. Okay, so this is after the lorry has been brought to rest. Now, because it's a constant braking force, which means that the deceleration is constant, so this will also be a straight line. Oops, ugly line. Let me erase again. Let me try to redraw for you. Okay, let me try to get it right. Okay, a nice straight line over here. So this will be how the graph looks, and that's how you're gonna get your 3 marks. Majority of the marks will come from you showing this part of your working. Okay, let me use a green pen to circle this whole part here. So you must be able to calculate what is the speed at 35 seconds, okay, which is over this part. Then you'll be able to get the rest, most of it, of the rest of the marks. Okay, so that's all.